We want to find the current in the circuit. We assume at one moment of time, the left side of the source is positive. Because of that, current is clockwise. We're going to do a Kirchhoff's loop starting from this point. We go through the source from negative to positive, we gain this much potential. We go through the resistor along current, we lose this much potential. When we get an inductor, because of Lenz's law or back EMF, this side is positive. So we go from positive to negative, we lose this much potential. And this side of the plate of the capacitor is positive because the current is clockwise, and we go through that, we lose potential, Q over C, we back up to this point, we call it 0. We differentiate this equation with respect to time. So differential of sine omega t, we get cosine, times the coefficient of the variable t, with omega here. And this is di dt. This is the second order derivative of time. dq dt is current. So we assume current as this expression, where I0 is the amplitude, phi is the phase angle, and they are unknowns, and we're going to proceed to solve them. We differentiate the current with respect to time, we get this, and we differentiate again, we get the second order derivative, we get this expression, and we substitute these two expressions back into the differential equation, and we get this equation. Now we divide each term by omega I sub 0. We now use trig identities to expand this cosine function and sine function and get this big equation. The coefficients of sine omega t give us this equation. From this equation, we can determine tangent phi. Now the coefficient of cosine omega t give us this equation. Now, knowing tangent phi, we can construct this triangle. With this triangle, we can determine cosine phi and sine phi. From a triangle, we sin cosine phi, we sin sine phi, and we substitute back into this equation. And we obtain this equation, and we solve for I0 to be this. In summary, we're given this circuit, and we're given the value of R, L, C, and V sub 0 and omega. And we assume I, the current as a function of time, to be with this expression, and we proceed to solve I0 to be this, and tangent phi to be this equation. If phi is greater than 0, that implies the voltage leads the current.